I'm just going to go through question 2. So it's very similar to the example that's in this at the very start of this exercise. It's basically looking at a base rectangle and then cutting little corners out like that light blue, dotted line basically, and saying that the height of the corner or the height that it's being folded up as is X height, okay, because we don't know what X is. All right, but we do know what the length is and the width is. So basically what we have to do is come up with, and I'm just going to use the CAS to show this. So I'm just going to go to a new page. Hang on, just go to a new page. And I'm just going to add note. Okay, so basically the first bit is from this diagram. I've got a 10 by 12 tray or a piece of paper, piece of rectangle, all right? And I'm going to cut little corners out that are X length. I don't know what length they are, but I'm just going to use that. And then I'm going to fold all the sides up to form basically the base of this tray, okay? So the edge of the each cutout square is X centimeters. Express L and W in terms of X. So of course, because I'm taking X away from W here, right, I've got the width. So I know the total width is 10, right? And I don't know what X is. So I'm basically going to write W equals 10 minus 2 times X. All right. And I might just write it as a, put it in a math box just so it looks better. W equals 10 minus 2x. All right, so that's the width because I can see the width is in total 10, but I'm taking the X part and the X part here away to give me what W is. And I can do the same thing for L. So I can go, the length equals, this time it's going to be 12 minus 2x. All right, so I've got the length here is 12, but I'm minusing the X and the X at either side off from that 12 centimeters. So now I've done A, basically. I've done A. All right. B says write down a rule for the volume. All right. So volume is going to be, and I'm just going to use the CAS here just to represent that. Be easier. So volume of a rectangular prism is basically the area of the base times the height. Now we know the height's going to be X, okay? I know the height's going to be X. So that means I've got X times the width and length, okay? So I can, because I'm using math boxes in the CAS, I can put W and L there, but I'm just going to write it out normally. So it's just going to be that, okay, times, and of course 12 minus 2 times X as well. So I've got that, right? So simplified, taking the 2 out of the first bracket gives me X minus 5. If I take 2 out of the second bracket, gives me, all right, and I can turn, like I can take the negative 2 out. So negative 2 times negative 2 is going to be positive 4. So that's why it becomes positive 4x, x minus 6, x minus 5. All right, because I'm factorizing these two brackets by negative 2, and I'm factorizing these two brackets by negative 2. So then negative 2 times negative 2 becomes positive 4. So that's where the 4 comes from, okay? And that's where this becomes x minus 6 and x minus 5. All right, and 4x. So basically it's a cubic, and you know that it's going to go through 0, right? Because of course it starts at the origin. Well, not starts at the origin. If you graph it, okay, it won't start at the origin, but you can see that it's going to go through 0, then go through 5, and then go through 6. All right, so it says use the CAS calculator to help draw the graph v against x for suitable values of x. Now, because I've done this in maths boxes, okay, in here, all right, I can just go copy, all right, so I can go copy, then I'll just do page, graph, and paste it in here. So here's my graph. All right, now, I can't see it, obviously, all right? So what I want to do is I want to sort of guesstimate what the x-intercept's going to be. What the y-intercept, well, actually, sorry, what the highest point of y is, okay? So I know it's got to be 30, 120 if I times that by 4. So it's got to be at least 120, all right? So if I do a window zoom, and I change the settings to -1 because it's not going in the negatives, and I don't care if it goes in the negatives because realistically it's a volume. If I'm talking about volume, I'm never going to have a negative volume, right? So I know it's not going to be that. I'll make that 8. 10's fine. I could have left it at 10, but realistically I know the last point of the cubic goes through 6, so I might as well just make it 8. Anything after 5 I don't want anyway, realistically. -1 for y, and then I said 120, so I'll do 150 just so I know that I can see it. So there's my graph. Now if you want it lower, like you can see there, it goes underneath the graph between 5 and 6. So obviously the biggest value that x can be is going to be 5. Okay, that's the biggest value that x can be. All right, so my domain that I'm actually after, right, if I was asking for the domain, it's going to be 0 to 5. All right, because I cannot have a negative volume. Okay, so it's fine to have a 0 volume, that's fine, okay, but I can't have a negative value of a volume, all right? And this is graphing the volume, all right? So there's my graph. Then it says find the value of v when x is 1, all right? So basically what you can do, because you've got your graph already, you can either go to table and split the screen on the table, and you can see the value when x is 1, which is going to be 80. You could substitute 1 into the equation. That would also get you 80. Okay, so there's a couple of ways you can do it, but if I've already got the graph, then I might as well get the table of values up. All right. I can do menu, remove the table. All right, so it's just a straight menu, right? Table, split screen table. All right, that's what you're after to get that. So I know then D is 80. It says find the values of x for which v is 50. So I could do a solve function and solve for, 50 equals 4x times x minus 6 times x minus 5. I can do that and solve for x, right? If I've got the graph though, I can just do menu, graph entry, graph function, and type in 50. Right, because that's when the volume is 50. Okay, and then what I can do is I can just do analyze graph intersection. So 0.51 if I round to 2 decimal places. I can do the same thing if I do analyze graph intersection and do, okay, so it's 3.56. All right, so there's 2 values for 50. When the volume's 50, it's when x is either 0.51 or when it's 3.56. Okay, so they're my values, and then it says find the maximum volume of the box and the value of x for which this occurs. So the only way you can do that is graph it, okay, because you can't estimate where that turning point is. So you're basically going analyze graph, maximum, this graph, boom, and there we have 1.1 1.81 for X, and the volume is 96.77 or 96.8 if you wanted to do one decimal place, right? But I don't think it says anything about decimal places in this question, so you might as well just do 2 decimal places. Most questions like this, either 2 decimal places or it might say 1 decimal place, all right? Most of the time it's 2 decimal places. So that's question 2. Question 4 is very similar though, all right? But the only, basically if I wanted to draw this, it's a little bit harder to draw it. It's a triangular base, all right? It's 5x by 12x by 13x. That's the triangular base. If you know Pythagoras, then you know it's a Pythagoras triad. Doesn't matter about the x. It's a 5, 12, 13 triangle, right? So that's why I know it's a triad. Okay, and the height of the prism is h, right? So if I wonder if I can. I'm not sure if I can draw that on the CAS. All right, but basically it's a triangular base and the height goes up. Okay. All right. So if I might do this. Add geometry, right? So menu, construct. I'm going to do shapes. So I'm going to do triangle. One there, one there, one there. Right, and then I might just quickly get out of that, and then do menu, and then I might do line segment, and go from that point up to here. Go from that point up to here. That looks about right. And from that point up to about, I'm trying my best here. So all right. So there's my triangular. That's my triangular prism. All right. So if I've got let's say this length over here is 5x, I've got 12x over here, 13x over here, all right, and h is this side here, all right, and it says the sum of the lengths of all of its edges is 180, all right, so all of its edges, okay, so in other words, that's the perimeter, okay, so if I do, let's go into notes again, okay, and I'll put into a math box. All right, so basically what it's doing is I'm doing h equals, right, and of course I've got to look at the diagram. So I've got 3 sides that are equaling h, and then I've got 5x, 12x, 13x, but I've doubled them. So I've got 12x and 13x is 25 plus 5 is 30, double it, which will be 60. So basically I've got 3h equals 180, all right, and of course plus what did I say, 60x, all right. So again, okay, I've got that. I can rearrange it for h. So h equals 180 minus, actually it won't be 180 because I've divided it by 3, so it'll be 60 minus and 20x. Right, so there's my h, okay? So that's just knowing that, in my triangle here, I'll try and give it so you can see, make a text box here, I think, just so you can see. That's h there, h there. If I do one down here, let's say that's 13x there, and I'll do one over here, which is 12x, and I'll do one here. Oops, I'll do one here, which is 5x. Okay, all right. not drawing a scale. Okay, not drawing a scale. All right. So there we go. That one's there, and that one's this length here. All right, so you see that's 20. That's basically 20x, 30x down there. Sorry, the 30x down there, 30x on top. Right, and then 1h, 2h, 3h. All right. So as long as I know that, then I can come up with all the sides, which is 3 times h plus 60 times x equals 180. Rearrange that for h. So now I've got the height in terms of x. That's A. B is find the volume. So again, volume equals, and it's a triangular prism. So it's going to be the area of the base, all right, times the height. Okay. So it's going to be the area of the base times the height. Now, because I know it's a triangular prism, because I know it's a triangular base, and it is basically, I know that there's a right angle in it because it's a Pythagorean triad. Okay. I can sort of assume that it's going to be half base times height. Then I use 12 as the height, or 5 as the base, or vice versa. It doesn't really matter, right? So I know that it's going to be 12x times 5x and halve it. So 12x times 5x, like if I do it in here, I'll just do it in here as a fraction. Actually, 12x times 5x. I'll just put it in brackets because I'm doing it as a, and halve it. So that's the area of the base. And then I'm going to times it by the height. So I get that. I've got h already. So, and I want the v in terms of, x. So basically I'm just going to go v equals 30x squared times 60, and you can see that like you take out, you can take out like -20 and stuff. So you can see there I've got -600 x squared times x minus 3. Realistically, it's another one of those volume questions that you know you're never going to get negative volume, right? But it's about getting the equation. So it's about just getting this equation, right, in its cubic form. Because remember, we've been doing cubics, and volumes are always going to be cubic equations, right? Okay. So again, we've got the graph. Like if it's asking us to graph it, of course, we're just going to do new page graph and put it on the graph. You know, sometimes it's easier to do this. You know, 600 times 3 is 1800. So it's going to be a very large graph if we're trying to fit it in, right? But you can fit it in and have a look if you want to. So there it is there. So it looks minute, but that's like to 10,000. So you might just adjust the graph window settings. Again, I don't want anything below 0. So I know it can't be anything below 0. My other x intercept is at 3. So like I might as well just put 5, right? If I'm going to graph this, I know I don't want any negative numbers, right? So I'll just make it -1. I know that it's got to go to, you know, they've put on there 10,000. So what I might do is, I think it'd be like maybe 3,000 might be enough. See, right? So again, I could probably go a little bit lower than that. Like it's 1800, right? -600 times -3, which is 1800. So it's going to be like about 2,000 would have been probably enough. right? But you're sort of guesstimating that. Okay, and then it says find the volume when x is 3. Well, then substitute 3 into this. 3 minus 3 is going to be 0. So you know it's going to be 0. Right? Okay, because this is going to be 0. Alright, when x is 3. You can see that on your graph anyway, right? So if I did analyze graph and did 0, right? So you can see there's my other x-intercept, right? If it was asking me to graph and show all the intercepts and stuff like that, well, I know that it's starting at 0, 0. I know it's starting at 3. Like there's the other intercept. Again, like it says, find the values for which volume is 1200. So menu, graph entry, function, 1200. Boom. Right, and then basically just analyze graph intersection. So intersection there, menu, analyze graph, intersection there. All right. So this is the power of you understanding how you use your CAS. All right. So then x is going to be 1 and x is going to be 2.73. All right, if it's 2 decimal places. Okay. So that's question 4. All right. And then question 6. I'm not going to do question 6. I'll let you do question 6, and then hopefully you can show me what you've done for question 6, and I'll work out, see if you got it right.